Well, good evening, everyone. Welcome to our February 2025 meeting of the Houston Electric Vehicle Association. And it's going to be an exciting meeting. We have John Nemec as our speaker today. And so that is going to bring us lots of really good information. I've went through his PowerPoint already, and it's really exciting. And at the end of that, we've got one of our members, John Atwood, with some hardware to describe. And then I'll also show a few pictures of where I'm at right now, which is not Houston. There's electric vehicles all over the world, just put it at that. So, okay. So Colin, you want to go through the meeting start?
All right, so I couldn't resist showing these slides again from 2024. Wow, it's a busy screen.
Yeah, these are really good. I like seeing all the different kinds of things that we've had going on. There was a Cybertruck there, another Cybertruck, IKEA. We're going to work on seeing if we can do that again in April. We definitely want to do Earth Day Discovery Green in April. So it's always good to show folks how we've successfully shown vehicles before. Big vehicles, little vehicles, big bears, lots of people. And so Wings and Wheels over at the 1940 Air Terminal Museum at the west side of Hobby Airport. And you can see we're having some fun out there, and electric buses are always good and important. And I'll show one of those from where I'm at right now. This year, we also joined the folks at the Houston Botanical Garden, which worked out really well a couple of times. So we hope to do that again in 2025. And I see there in the right photo, the i3, and we're going to have Eric talk about his i3 at our meeting here today. And so, yeah, here's a summary talking about events, people, EVs displayed, ride and drives, events. So this is for the overall organization. And so, yeah, there's been a lot of fun in the last year. We're going to have a lot of fun this year, too. So here's some general info on those. For us, 10 meetings, 10 videos. So these are always recorded, and they're available on YouTube. You can look us up, Houston Electric Vehicle Association. And as I mentioned, April has Earth Day in it. It's going to be on the 19th this year, because they always like to do that in Houston on a Saturday. And so yeah, you can suggest a location. We're going to work on doing the Discovery Green in the middle of Houston, and then also the IKEA, if that works out. We understand that they just transferred to a new representative who coordinates with organizations like ours. So we'll see if that works out. So, and of course, we always encourage folks to join the national organization. We have no dues for our Houston chapter, but if you'd like to join the national organization, we get a little bit of a refund of the dues that you pay for that. And of course, that helps sponsor events going on all over. And then there's an annual meeting. I've gone to that in person. You can also join that remotely. And that's a fun thing. We always like seeing people join the national. And these one sheets are one of the things that we get from the national organization, and they always become dated very quickly because of the new vehicles that keep coming out from the different manufacturers. Of course, our club started folks doing conversions, and now we're proud that we still have members that like to do conversions, but of course, a lot of our members buy built EVs that are being produced in larger and larger numbers. And I think John will mention some of that in his slides. And other fun events like the road rally that shows here of Rivian.
Yeah, we have a member who'd like to set something up in the road rally, and we haven't gotten very far with that. Or with EVs and beer. It seems like we could drink beer pretty easily.
Yeah. So yeah, everybody, of course, in the club is welcome to suggest things, and we'll see what we can get organized. Our staple are these monthly meetings, but as you saw, we've got these events like the Wings and Wheels and so forth. And EVs and beer is something that we'd like to get set up. Maybe in one place in Houston, maybe in multiple places in Houston. It always takes so long to drive across Houston. And so that would be something. So if you've got a particular location, maybe near where you're at, some of us will on occasion drive long distances to join up with an event that someone has recommended a location for. So by all means, speak up if you've got a good location you think would be nice for people getting together. And then of course we always can walk out to a parking lot and see new vehicles. Eric, did you happen to bring your new Ioniq 5 today?
It's here.
Here, all right. So the people that are in person there might have an opportunity. If you tap Eric on the shoulder, maybe he'll show it to you at the end of the meeting. That would be nice. And I hope to see it, say maybe a month from now or something like that. So good. That's great that you got the new one. So TXRX has got lots of things going on. We really appreciate getting the use of space for free from them. And of course, we always like to make known to people who might be able to make use of a lot of the tools that are available. They just do a safety checkout for use of those tools, and then either for no charge or very nominal charge, make those available so you don't have to spend a lot of money for a tool that you might only use once. And then you also get to interact with other folks that are maybe doing something similar or different, but using the same tools. So yeah, getting more involved with TXRX is always something I recommend. And so I think that takes us through the slides we want to show at the beginning here. As I mentioned, I've got a few things at the end that we want to bring up. Yeah, it's always good to have some visual things to help go along with what people are talking about. So if you're about ready, John, I'll go ahead and introduce you, and we can have you either up at the front of the room or wherever you feel most comfortable. But John has got a lot of experience as a licensed professional electrical engineer. So yeah, he can really delve into things. I see that his background includes high voltage transmission and distribution, substation design, RTU programming and commissioning, and custom automation logic for industrial power distribution systems. So obviously getting very deep into things. But today he's going to talk about how EVs and the utilities interact. And so that's great that he's going to talk about technologies and ways to design and build our critical infrastructure. And his employer is Burns and McDonnell, and that's great. And so I will turn it over to you, John.
Sure. Yeah. Can you all hear me okay from here? Is that, if I just.
I can hear you online fine. Thank you.
Okay. Cool. So yeah. Thanks for having me out to present. Been to a few meetings, maybe one in person and one online. So I'm kind of dipping my toes into getting more involved. So I work in the transportation electrification industry, and so thought it'd be maybe pertinent to do a presentation. So yeah, here to talk to you all about what transportation electrification means for electrical utilities. So a little bit about so a little bit. No problem. So a little bit about me. So yeah, as Dave mentioned, I'm John Nemec. I'm an electrical engineer work for Burns McDonnell, doing EV charging infrastructure, have a background in doing substation design, so building out the power grid, and then working in SCADA, so that's kind of communication systems in the power grid. And I am an EV driver, so I feel like it's appropriate for me to be part of the group. Here I drive the Kia Niro, and yeah, it's been treating me well since 2022. So Burns & McDonnell, we'd like to start meetings and presentations with the safety moment. So Oh, I guess the top of the slide's cut off there, but anyway, I guess that's. So thought we'd talk about defensive driving. So, just cultivating the habits of being thoughtful on the road and anticipating the actions of others, being a predictable driver, and sort of understanding the capabilities of yourself. So you set yourself up for success on the road as appropriate as a EV charging club. So part of what Burns McDonald does is a lot of different things. We're a consulting engineering firm and construction firm, and we work in aviation, federal, and global facilities, building out like the Cheeto production line. We also work in transmission distribution, which is what I guess the business lane that I'm in. And then within that, I do transportation electrification. And so within transportation electrification, there's a lot of different parts and pieces to that, whether it's like analyzing the business strategy or figuring out the power grid system impacts, which is what we'll kind of talk about today. Looking at different commercial fleets to see is it feasible for them to electrify, like are they good candidates for that, and then committing these like kind of roadmaps to get the infrastructure installed. Doing a lot of variety of things there. So today we'll talk about kind of the utility piece of that pie. So looking at this, kind of thinking about the problem here with reasons why electrification is important for them to be thinking about is the kind of the growing market of electric vehicles. I think I'm probably preaching to the choir here as far as understanding that EVs are becoming more and more prominent in the world today. And so I grabbed some data from we have access to some of these like data aggregating firms. So this one's called Atlas Hub, and they put out information on the EV market sales by quarter for the past couple of years, and you can see that's pretty steady growth. I think that this data maybe lags a couple months. I grabbed it last month, and so 2024, Q4 2024 may not be the full picture there, or it might be. I don't know. I tried to find some information on why that is such a big drop. A lot of other things happened at the end of 2024 that maybe affect electric vehicles. So, and then I thought it was kind of interesting the EV sales by state. Being that we're in Texas, seeing that we're number 3 on the chart, I thought was kind of an interesting data point. So it all just goes to show that electric vehicles are becoming more and more popular. Kind of dialing in a little bit further on Texas, looking at the EV sales share. Here we see that kind of has been pretty steady growth for the past couple of years, and in 2024 we kind of ended up at around we'll call that 7%ish. Kind of hard to see exactly, but keep that 7% number in mind for later in the presentation. So more about the EV market. So this is kind of like the cumulative sold and upcoming EV models by year and this kind of vehicle class category. So you have like your light duty vehicles, which is be like consumer vehicles like you and I would drive. Kind of medium duty vehicles, which maybe like a U-Haul or a box truck type thing, and then a heavy duty vehicle, which would be like a Class 8 semi truck. And so you can see that starting looking at data in 2010, there wasn't too many different types of models, but as we're getting into like the 2020 to 2025 time range, kind of where we are now, there's a lot more of these EV models hitting the market, and then a lot more of the heavier class, there we go, models. And so with these heavier duty vehicles, the charging power that they can accept is a lot greater. And so as these vehicles come online and are looking to get power from the grid, that's something utilities definitely need to keep in mind. So what does this power demand look like, and kind of how can we put this in realistic terms that we can easily think about here? So and this is kind of looking at it from perspective of like a depot type charging. So maybe not necessarily like a consumer charging like we would deal with on a day-to-day basis, but if you think about 50 vehicles that are charging, like from a fleet that's like, a class 1 or class 2 vehicle, it's looking at 360 kilowatts, which is, decent load, but nothing too crazy. You get into the medium duty, 750 kilowatts, that's really not that difficult for utility to bring that kind of power to a facility. Some of these like larger buildings are looking at getting into the megawatt range. So like the Transamerica building, 2 megawatts. And then so like looking at a bus depot, that'd be equivalent to dropping a decent sized building at one facility for the power demand that would be required there to charge those buses. And then when you start looking at the class 8 semi trucks, you start getting the idea that it's like an Empire State Building. It's good amount of load for utility to have to consider to bringing to one location is not necessarily the easiest thing in the world for them to do. So yeah, just kind of like putting into real terms, or something that you and I can maybe think about is that like a depot that would charge these buses is akin to like a block downtown of power demand for a skyscraper. So here's kind of like a slide talking about the power demand or the electricity generated in the U.S. Looking at the starting in the 1950s and kind of going today. And so looking at these different time frames of about a 20-year gap. So it's like 1960 to 1985, time frame. It's about a 20-year span. And that goes up about 1,600 terawatt hours of energy generated, added to the grid, we'll call it. And then again, in another 20-year span, we see there's like a linear growth. And so another 1,600 terawatt hours. It kind of levels off in like the, 2005, 2010 timeframe. And that's kind of when a lot of like efficiency efforts came out, right? So like you see these like the LED light bulbs or like your appliances that get the Energy Star rating. And so there's still a lot of consumer demand for more electricity, but we're having more efficient products out there. But so these groups, the American Transportation Research Institute, I think is what ATRI stands for. They did a study that if we went into full transportation electrification of light duty, medium duty, heavy duty vehicles, that would be another 1,600 terawatt hours of energy required for those batteries on the grid. But as you can see, over the last 40 years, more than 40 years now, but over the last period of time, we've been able to meet the demand needed for the growing electrification of appliances. And so it's all to say that it's doable. You hear people have like the stories in the news or like, kind of like the fear and uncertainty type thing of like, oh, if we electrify everything, the power grid can't necessarily handle it. Well, like, the amount of growth that we would need for full transportation electrification is something that we've done twice already in the past. And so there's nothing to say we can't do it again. I'm not going to say it's going to be an easy thing for us to do. And we're not looking at just EV load, right? I mean, there's data centers and other, power demand that will be part of the equation. But for transportation electrification, there's certainly a history of being able to meet that.
And I guess also for the increases, a lot of folks are talking about AI data centers are gonna up the demand quite a bit.
Absolutely, yeah, for sure.
Okay.
Yeah, we can talk about that a little bit later on too.
Okay.
So kind of what utilities need to do in order to kind of meet this demand and provide the energy that's needed in the power is to think about forecasting what the EV load potentially could be and start planning for that. And so whenever they think about forecasting this, like EV load, they follow this idea of the fusion of innovation theory. And so the idea here is that there's like kind of the innovators early on. So think about people who are buying like the Tesla Roadster, spending hundreds of thousands of dollars on these vehicles that are just super excited about having electric vehicles. Those are like the innovator type folks. And then you get your early adopters, which is like, okay, we're still at the beginnings of the adoption here, but we're willing to like put ourselves out there to get this new technology. eventually you get into your early majority, your late majority, and your laggards. And so it kind of follows this bell curve as far as the quantity of people who are, getting these vehicles at these different stages of this cycle. And so as you plot that on like a market share percentage, you get to this kind of S curve type model here where, as the fewer people, like the innovators are getting it, you're at a pretty low percentage. And then as you get to the early majority, late majority, you get a pretty steep curve on that, S curve, and then eventually laggards join on and it flattens out a little bit. So this diffusion of innovation theory is kind of an interesting thing to think about for past technologies we've had to deal with. And this is kind of a famous graphic of, the different new technologies hitting the market and how they're all being adopted by consumers. And, they're not perfect S curves like we saw in the previous slide, but they all generally follow a kind of trend like that. And so,
Well, right in the middle there, you had a world war, so that's why some of them cratered out.
yeah, there you go. Can you see my cursor on this? Yeah.
There it is.
One of my favorite ones on here is color TV, where it has a pretty steep adoption curve, but it never quite hits 100% in 1990. So I don't know who out there is still watching a black and white TV in 1990, 2005, but I guess never far. So anyway, there's this idea of the fusion of innovation. And so what we can do is we can take this theory and then we can apply different models to it, where it's like, okay, do we have kind of an accelerated adoption curve, or like maybe a more aggressive one, or do we look at an average or a delayed one, or like really slow? And looking at the different time periods with these different scenarios, we'll call them, what does that adoption percentage look like? And so there's the trend setting, transition period, and the mass adoption. And so I think you talk to different people will have different opinions on which of these, models we're on, and, where on that S curve we actually are. Are we on that, this kind of early phase right here, or are we starting to reach this knee point where we're going to have this like really rapid adoption, or is it going to, or, like we're definitely not, in this linear portion.
And it kind of also depends on what country. If you're talking about just the US, which I imagine most of your work is, or if you're looking at data from around the world, I think countries like China are way ahead on adoption.
Absolutely. Yeah, good point.
Mhm.
Yeah, and there was a theory I heard that whenever, like, how will we know when we are at this kind of point of, hockey stick moment or whatever? And they said that's when a really good electric truck hits the market that's like, available to like the mass consumption, because, as Americans we're like the truck, give me my truck kind of America. And I don't know, like there's really respectable electric trucks out on the market right now, but I'm not sure if we've reached that knee point or not.
Well, there's the Rivian that's out there.
Yeah, for
Mhm.
sure. So then once you take these different models, you also have to consider these different use cases. So there's the residential model. So that's going to look different than like a public, charging stations versus a fleets. Residential, it's different things to think about with like the transformers in a neighborhood on distribution lines versus like a commercial fleet where it's like they'd want to have a dedicated service, like building out power lines to the location to satisfy that power demand. So what you can do is you look at these different models and you look at these different areas and you create what we call a propensity model for forecasting EV adoption. And it's kind of a little bit of a mouthful to say, but it's like, what's the odds that this area, this like service territory, this utility is providing power to, will have electric vehicles in it, and do we need to start preparing for those electric vehicles? And so what we'll do is we'll evaluate like who's buying the EVs today, what are the important factors of adoption, kind of do some analysis on the adoption rates, looking at census tract type stuff, do some forecasting, and then develop these like models for the residential, public, and fleet, and then, create these kind of cool visualizations like this where, utility will know, okay, we've got different circuits in these different areas that are providing power. So do we need to start thinking about upgrading those? And we'll talk about that here. And so then you start looking at what are the grid impacts to the electric vehicles as they're coming on. So, you get the different equipment impacts that are out there. So the additional load causes thermal loading that may cause issues in certain devices like transformers and switching devices on the power grid. There's potential issues with phase balance, depending on, how the facilities like the fleets are building out and who's charging where and when, and the different residential facility, models where you have 4 houses that are all next to each other on one service transformer that's coming off of like the B phase. So if there's ABC, there's 3 wires going across the back of your neighborhood. And they're all on that one phase, and that's how they loaded them up, down throughout the neighborhood. And phase imbalance could cause issues on certain, pieces of equipment. Load volatility, so like the models of EV charging is a little bit different than typical loads that maybe utilities are used to seeing, and some voltage profile kind of stuff where maintaining the voltage becomes more of a burdensome task because the EV load increases. And so you start looking at what are some proactive upgrades that utilities can do. And so the power grid, there's these they call them substations, right? So that's like essentially the transforms power from high voltage to a lower voltage to do transmission down to distribution. And so do we need to consider upgrading those substations, or maybe even the feeder lines that are going out from the substations, if they're being risked overloading? Are there certain conductors that are going to be choke points as we're requesting more power along that line? Is there going to be like transformers that are most likely to fail first based on age or demand or like area that they're located in? So would there be proactive things that utilities need to consider doing to upgrade the circuits there? So looking at these different models of adoption and the different requirements that may be needed for how utilities can mitigate this, looking at the kind of a status quo low EV adoption, so less than 20%, which is kind of where we're at here in Texas, right? We saw on the previous slide that we're in that somewhere between 6 to 8% adoption. So, and just like your traditional planning that a utility would do, where you're looking at maybe doing some phase balancing, you have these reactive power devices that you can put out on the grid to help with voltage, the voltage profiles. Maybe consider doing some line rebuilds or reconductoring, which is maybe more of a typical utility type of thing that they're doing. Then there's the idea of, well, okay, whenever we get to the 20 to 40% adoption, which is, pretty good way up that S curve, what does that look like? And so there's these 2 ideas of having a managed charging from the utility perspective or an unmanaged charging, and we'll get into that in a second. But with managed charging, you're able to kind of keep that peak load increase to like a more reasonable and more manageable kind of zone. So they're saying that a 20 to 40% adoption would equate to a 40 to 60% load increase on the power grid. And so whenever you start seeing like stuff like that, you may have to consider voltage conversion projects and some pretty major system investment. And so with voltage conversion, if there's the power lines in the back of your neighborhood, back in your backyard, if you have power lines in your backyard like I do, maybe those are at like a 5 kV or a 12 kV. And so maybe you may need to consider upgrading that to 34 kV or something like that to be able to help mitigate some of that. There's maybe some system reconfiguration where it's like, okay, if we're feeding the power to this specific area and, along some power lines, maybe do we need to bring different power from a different set of power lines by, adding switching, devices on the grid. So there's like stuff that you can do there. There's also like doing some rates type stuff for the managing charging or providing incentives. And then there's like active managed charging, which we'll talk about here in a second. And then you look at it with unmanaged charging, where it's like, you're not really putting too much effort into helping to get around that load growth. And so a 20 to 40% adoption and with the load diversity would more than double your load on the grid. So you definitely need to consider voltage conversion, looking at some V2G type options, or at some DER deployment, which is distributed energy resources, so like non-wire alternatives to help mitigate the load right there.
So John, when you talk about managed or unmanaged, are you referring to, a real physical control of the charging, or are you thinking more of like people who have vehicles they can set to charge in the middle of the night? For example, I have my car set to be ready to go at 6 a.m. So it starts at different times and different nights. It's not like it always starts up at 2 a.m. or something, which I would think could also kind of be a problem if you had everybody in the world, had their cars all turned on to charge at 2 a.m. That might be undesirable too. But mine's going to start all different times because it's set to stop at 6 a.m. at the level that I've set it at. But are you talking about managed as in, I remember that there used to be some options where you actually would have a separate circuit and meter and so forth, and it could actually be controlled by the utility? Or are you talking about more folks just setting their cars, in which case you got a certain amount of trust, I guess, that they're really going to manage it?
Yeah, it's a great question. So you're a couple slides ahead of me there. So there's different utility programs out there that they can use to help mitigate that. So I'll jump to that in a second, but yeah, just thinking about the mitigation efforts here. In order for a utility to prepare for potential EV adoption, you need to do your data analytics, look at the EV market trends, think about EV programs, and then work on the grid hardening. And so, yeah, Dave, what you're kind of talking about here is these like utility programs and managed charging, and like, what does managed charging mean, right? That's, kind of there's a lot of meaning behind what that word can mean. So there's the idea that there's like a passive managed charging program, and then there's active managed charging programs. And so I think kind of what you're talking about with what you do, where you set your car to be like a certain time that it starts charging, that's utility is not really actively taking actions there for that to happen. That's something that you're doing yourself. But what the utility can do is they can provide like these time of use rates, where it's like we incentivize people in our service territory to not start charging when everybody gets home at 5:30. To where we set a new peak in the power demands. Maybe we have them all start at midnight or 2 a.m. or something like that. We incentivize that by putting out this program where it says, okay, we'll reduce your give you free electricity or reduce your rates if you charge between these periods of time, and we'll reward you like with like monthly things or whatever. There's different utilities do it different ways. And then there's the active managed programs, and so utilities have this for different types of customers, like in the industrial world, where they issue these demand response events where, hey, we know that there's going to be a large demand on the grid at this point in time. If you participate in this program where, you say, I will cut my load by half or a certain amount of megawatts, then I will get paid from the utility to do that kind of stuff. And so utilities are looking at doing that with electric vehicles at people's houses. And so there's this company out there called WeaveGrid, and they've got a system. Right now it only works with Teslas, but where you sign up with their program, and WeaveGrid will go in there, and you can say there's a lot of parameters you can set in there where it's like, okay, I want to make sure that I'm at least 80% charged by 6 a.m. so that I can leave the house. WeaveGrid, you can figure out what that charge looks like. Maybe it's I only charge at 1.5 kilowatts for an extended period of time, or I can charge at like the 7 kilowatts that my charger is capable of doing at my house, which or 3 kilowatts or somewhere in the middle. And if enough people in the neighborhood that is the issue sign up to do something like that, then that can really help the utility. mitigate the power peak power demands that would happen there. Utilities are also doing these different services that they're providing. So these make ready programs. So essentially, if a commercial client in their service territory tells the utility like, hey, we're going to bring in electric vehicles and we'd like some support, financially for doing stuff like that. Utility may provide money towards that, knowing that that's going to be a steady revenue for them because they make money by selling electricity. And so they have certain, ahead of the meter, which is like the distribution power lines, and they have certain behind the meter programs, which is, the actual wires in the ground and the chargers, at the parking spaces, for instance. And then we see a lot of utilities out there that are kind of leading by example by electrifying their own fleet. And so, here in Houston Center Point, they've got goals to electrify their fleet. I think it's 100% of their light duty vehicles. So that's like the Ford Escape type vehicle, whether it's either going to be electric or hybrid. And then they want to do 25% of their like medium duty trucks, so like the F-150 Lightning, and then 10% of their aerial vehicles. And so, I worked on the program to get the engineering design done for them. There's actually right here by TXRX, there's the navigation facility. They've got some EV chargers like right next to us. So they're going to be bringing in more electric vehicles over the next 20 years as their fleet is turning.
Yeah, just to relate another story about our club and Center Point utility vehicles, and in particular a bucket truck. We had a speaker a few years back, and they had one trial electric bucket truck, and they were worried that their line workers weren't going to like it, and it turned out to be just the opposite. They loved it, and the big deal was the traditional bucket trucks have to run their engines in order to have hydraulic pressure to raise the bucket up and down. And when it's electrified, you don't have to have the vehicle's engine running. And they could talk from the ground up to the bucket and back very easily when you don't have an engine running right next to your head, because you're talking up to the guy in the bucket. And so that was, just something they learned that they didn't expect, is that all their line workers wanted that truck because they only had one of them at the time.
Yeah, that's good to hear. Yeah. I know there's a lot of like intangible benefits to electrifying the fleet, something kind of like that. Another one I've heard is people that drive semi trucks, like those Class 8 trucks for a living. They go out and do their routes during the day, then they come home, and their significant others like, oh, go take a shower, you smell like diesel, like, oh, this is awful. But when they drive an electric truck, they come home, it's like, oh, you don't smell bad anymore. Like, oh, not only is it better for the driver, but it's also better for their partner back at home. So
yeah, I could see that.
So yeah, this is my last slide. So this is like some of the other talking about the utilities in Texas and kind of what they're doing with transportation electrification, their programs out there. So this is Desire Insights, is where I got this data earlier today. And so, in 2024, Texas regulators approved these electrification programs for a couple of different utilities here in Texas, including Entergy, who they approved to actually own their own charging infrastructure. And so, there's different utilities in the United States have public chargers that people can charge at. It's owned by the utility. And so I think Entergy is the first one here in Texas to do that. And then, some of these trends of what utilities are doing towards, these active charging models, kind of like I mentioned before. A lot of them are offering these rebate programs for purchasing. I don't want to speak too in depth to like a lot of these programs because I don't know a ton about them and it's a little bit out of my lane, but I know that there's a lot of these like number of actions that utilities have taken across the United States for these different categories of, doing these like EV rate designs, grant programs, tax credits, DC fast charger deployments. So anyway, it all just goes to show that utilities are, thinking about electrification. It's definitely top of mind for them and something that they know is coming. And there's a lot of different solutions to the problem, and a lot of people are trying to figure out, the best one that fits their service territory and their customers. And yeah, interesting problem to solve and interesting thing to talk about. So this is my information if you want to look me up. And yeah, Burns and McDonald, we are allowed to create a business. Anyway, thanks for letting me present. Hopefully that was interesting. Yeah.
Oh, that was super interesting. Thanks so
Yeah.
much. And
Anyways.
of course, we really want you to keep coming back to meetings, just, all the time, John.
Sure. Yeah.
It just would be great. And so I'd like to encourage folks to, if you want to, put questions in the chat, or you can ask live. And I see Emma's got a hand moving. Or is that clapping? It
was clapping.
it looked really tiny on my screen. So at first I thought it was kind of like a waving hand. Then I
Well,
maybe it's-
John, this is Ken Gathright. What about, I guess a year or so ago, it seemed like transformers, power panels, I may make up names since I'm not electric engineer or anything, but you couldn't get them. It'd take a year, because the whole thing was, involve the utility way before you even buy your, electric. And this is more for heavy duty, trucks, but is that still an issue as far as the supply of transformers and such that you would need?
Yeah.
Okay.
Yeah. And I'll give you every engineer's favorite answer to that question is that it depends. So
I'm
yeah.
actually in that business. I don't buy them, but I quote those type of transformers all the time. So you can get the 2 to 3 kilowatt. Those take a year and a half to get in. You can order 100 of them and you can get them in a year and a half. You can order one and get them in a year and a half. But the bigger ones, the 12 megawatt and larger up to 75 megawatts, those take 2.5 years to get. We could order it today, which you can't because it takes 15 weeks to get it all engineered and approved. And then you got a 2.5 year waiting period from that's Hitachi or ABB. And some of the other ones are worse and some are better. So I mean, if you get it from Mexico, it may be a little bit better than that, but you're still talking 2 years out.
So John Sweet, do you know why it takes so long for that piece of equipment versus other pieces of equipment?
That's back order. That's how many have been ordered. They can build 250 transformers a day for the pole transformers that you put in the back, like on the backyard on the poles.
Yeah.
They can build 250 of those a day, and they're backed up for a year and a half. It's incredible. And the 2 to 3 megawatt, 1.5 to 3 megawatt transformers that are going to the data centers, they're wiped out. The 1.5 to 2 years it takes to get those. You can try to spend more money to get them faster, and they'll order them from Brazil. It's because money matters, but all the factories are full.
And
You can't build them fast enough. So they're actually going to South America factories. And the shipping cost is a little bit more to get them here, but the time frame, you may save half a year.
okay.
It's incredible.
They're made in the US.
Oh yeah,
Oh,
that we build here because it's too expensive to, and it's got to be UL labeled. I mean, depending on who's buying it. If it has anything to do with oil and gas, forget it. It's got to be UL labeled. China still will say it's UL labeled, but you have to go there and check it all out, especially the big transformers. But then you got shipping costs.
and Brazil is making them.
Correct.
Wow.
ABB Brazil is making transformers for the United States today
Wow.
because all our factories are full, and they're building new factories. They're doubling the capacities of the factories here. We
I was just going to ask that.
and most of it's data centers. Some
Okay.
of it's solar, some of was Bitcoin, but those kind of fell off the market for a while.
But the data centers demand is, even the newly built factories aren't keeping up. Okay.
with the certain size transformers between 1.5 and 3 megawatts, you can't get those for a long
It's
time.
not trivial to just go make those. You have to know what you're doing.
Yes,
And I've spent over 2 decades in motor controllers. Kind of like what you find in your cars. And about 20 years ago, you couldn't get the transistors for love or money.
yeah,
And the company I was working for had orders in with the 3 big suppliers. They were redundant. It's more who was able to ship you the parts
Faster.
this month.
yeah.
You would build with that. And then when they finally caught up with the supply, then all the sales reps were calling you saying, I've got stuff. Because people had double and triple ordered, and then they started canceling all the orders. And so I could imagine companies like ABB going, we're not doing that.
No, they're
They're not gonna go and just build, like you got demand, but they're not gonna build the factories because they're gonna be very cautious about building the factories because they don't want to end up with a factory that there's no demand for it.
the demand is there. I mean,
Yeah,
the
but-
data centers are pulling they're pulling all the steel, the magnetic steel.
Right.
That they build cast coils instead of oil-filled transformers
Yeah.
because they're available. Not because that's what is spec'd out,
Right.
but that's because that's what they're available.
Right.
And so that those transformers have to have different type of cooling, maybe indoor air conditioning. It's like,
Yeah, but
you're changing the
there's
entire,
demand today, but the big companies are leery about, will there's actually be demand in 5 years? They don't want to be stuck with a plant that sits empty.
I got a question.
Yeah.
So we don't have vehicle to grid protocols. Australia maybe does. Their grid may actually be up now. I know that they were looking at January. Is that on anybody's radar? Or what are they talking about?
Yeah, the vehicle to grid thing's a super interesting like topic to dive into. And there's like the V to X, like V to home, V to load, V to grid. And so for like the vehicle to grid, you're right that there's no, like, they're still working out the protocols for that kind of stuff. And it's a little bit of the Wild West. And I think that, if you were to ask me, like, is it possible for us to do vehicle to grid today? There are cases out there where they've, proven that here's a depot that has electric vehicles and we can do vehicle to grid, but it's a very bespoke solution where it's like, okay, this one utility in this one area with this one client using this one control solution, we made it work and we did it for 3 months and then we, give everybody high fives and now we don't do it anymore kind of thing. So in order to like build like that standard protocol that everybody's going to follow and everybody's going to agree to, it's a little bit more of a journey to get there. And I don't think we're quite there yet. Will we be there next year? Probably not. Will we be there 5 years?
Is part of it getting all the vehicle manufacturers to agree?
Part of it?
Because OBD is supposed to be standard,
Mhm.
but it really isn't. It's really all their different standards kind of mushed together.
Yeah, I think it's the vehicles and it's also the chargers too. It's like the charger, the hardware, like, that connecting piece that goes to the grid, like it has to have the technology in it and the controls in it and the communication in it. And like, so, those are 3 pieces of the puzzle that are all working independently, doing their own thing, and some people within those entities are focusing on D2G, but that's not their main priority. And so it's like, so you're right.
So are they excited about it for the problem solving possibilities, or are they just like, man, we'll see it when it happens?
Yeah, I think that it's probably more of like a thorn in their side at this point right now. I think that there's people out there that are excited about it. But I think that, utilities work hard enough just to keep the lights on. And, I think with like the distributed generation, like solar panels on your house was like already a pretty big challenge for utilities to kind of have the net metering and, mitigating this, like all these points on the grid that are now contributing instead of just, taking. And so how do you look at that as far as like a grid management perspective? And so
add the V to G on top of that, like it's,
So there's not like a prevailing idea that V to G is gonna fix all those things. It's that the idea is more that it's going to compound the problem.
I think that people are seeing the challenge right now, yeah. But I, at the other side of the map, they're probably like, yeah, I mean, it'd be great if we could get it all working,
You're probably more
You
like,
figure it out.
you're probably more likely to see it realized in a place like China where they have a central government that just dictates, you will do it this way.
Wait, we have one of those.
Yeah, like
And
Switzerland's the same
enforce
way.
it over a protracted period of time. Like here, you can have, you elect, one administration and they're there for 4 years and then, but it takes more than 4 years. And then someone else takes over and they have a different idea.
Yeah, and like investing in like utility investments is like super long-term investment,
Yeah.
right? Like they're looking at like 30-year time span, like,
I was just watching a documentary on the cell phone industry and their history. And it sounds a lot like what you're talking about. All these small companies had their standards. And then they all want to make their money. That's another
Yeah.
thing missing. Is the government doesn't care about making money either.
Yeah.
So all these companies want to make their investments back. So they're pushing their standards. And yeah, eventually they all start realizing that there's some good ideas that they could all kind of, but like you just said, they squish them together. They don't make one standard out of it.
Yeah.
So, yeah.
yeah, will there be like consolidation in the market that
Right.
like maybe drives us in one direction or the other? And I think we're seeing that with different EV charging manufacturers going out of business, over the past couple of years. And so it's like, will the survivors all kind of like figure out how to make it work?
Yeah.
I think from a technological perspective, like we can do it, like it's been proven. It's just like the market forces behind it, and the money making forces behind it, all that kind of stuff too.
All the egos of the people running all the little companies.
Yeah.
And if I want to do it my way.
Mhm.
So, John, thinking of things about the grid, you have a slide titled Grid Impacts, and it reminds me of something I heard maybe particularly in Hawaii, that some neighborhoods are really having problems with too much solar and things like that, because the grid in a lot of the neighborhoods were built to go one directional. And then when you end up with all this solar and you end up with a mild day and people aren't using a lot of AC, you can end up backfeeding in neighborhood. Is that a problem that you've seen?
Yeah, I mean, there's a term for that that's escaping me right now.
Need for vehicle to grid.
Yeah,
Need for a
I
battery.
know how you could fix that.
yeah, I mean, yeah, solar plus storage is definitely like a kind of a solution there. But it's like you have the ability to generate electricity that you choose not to because the demand's not there. And there's a word for that, but I'll probably think of it.
Curtail?
Curtail, yeah. Yes, exactly. Yeah. And so, yeah, and it's like, okay, if it's, I don't know, and this is getting a little bit out of my lane because I'm an EV charging infrastructure guy, but, what kind of contracts do you sign with the houses that are generating electricity, and, if they're capable of doing it, but the grid can't take it, like, what does that do to it? I don't know. Yeah.
You can't get approved if it can't take it. There's one guy, I don't remember his name, Bruce or somebody on it, Reliant, or Centerpoint, that you call up and then they do a study on the transformer in your backyard and whether or not you can push up to it and the right amount and all that. And if it's got to be beefed up, they tell you whether or not you can, or how much you can pay to get it beefed up.
Yeah.
He's the guy that comes out in specs too, right?
No, Bruce stays in the, well, he didn't come out to my house. I had some guy from apparently had come out and didn't even know I was out there. So what are we doing today?
That was the city.
That's true, that was the city, but they were the ones that put the sticker on.
So I heard somebody mention batteries. I wanted to ask you, John, about what you see happening with big battery farms being attached to the grid.
Yeah. Yeah, it's definitely a thing. It's expensive, I think, is, probably the reason why we don't see more of it. You gotta think about like what the use case is for the battery. And are you, some of the clients we work for, they get real excited about like, okay, we're doing EV charging, like, all right, let's get solar panels out there and let's put a battery also, and like, let's just do all this stuff. And then we'll do the study for them, is it feasible to do that kind of stuff? And then, we blow them out of their chair with how much it's gonna cost, and then we pick them back up and it's like, okay, let's talk about what you really wanna do, and like maybe come up with like a solution that, meets your needs, but maybe doesn't go all that way. And so it's like, for the battery, it could be used to mitigate some of that demand. So if like, you saw the graph that had the semi trucks where it's like, okay, if you're gonna have a fleet of 50 semi trucks that need, 90 megawatts or whatever it was, I guess.
Yeah, I was amazed at how much a semi draws. You had that on your one chart. It's like, wow, as much as a skyscraper.
Yeah.
That was 50 of them, right? Or 20?
It was 50.
50,
Yeah.
yeah, that was 50 of them.
Okay.
The 150 of those skyscraper.
Yeah, so 50 trucks, 9 megawatts. So like, if the utility is saying like, hey, we can only get you, 2 megawatts a year from now, are you gonna want to get those 50 trucks? So it's like, okay, well, this is part of our business plan and we've worked out, whatever that we need to get these trucks. So maybe we'll put a battery in to mitigate some of that peak demand so that like, whenever, that the 20th truck plugs in and that exceeds what the utility grid can provide, the battery kicks in at that point. And so does the cost analysis make sense to provide the battery there, type thing? Stuff like that. So yeah, there's that, and then there's the resiliency aspect of it too, where it's like, okay, if we're expected, like we lose power regularly at this facility, but we want to have EV charging going on there. So what kind of backup stuff do we want to do? Like, we're bringing in EVs, so we don't want to put a diesel generator because that's not meeting our goals here. And so maybe we want to spend the money to put a battery in. So, and then like, okay, putting a battery in, maybe solar makes sense at that point too, because you've got a giant warehouse, but there's like square footage that you can maybe get a couple, like a megawatt from that, or so yeah, it's definitely something that the clients that we work for look at doing, and sometimes it makes sense and sometimes it doesn't. It depends.
So there's of course big battery installations, and then there's individual homes that have batteries. And I see that Jim Thompson has dropped off, but maybe we need to get you and him together at a EVs and beer evening. He's got a power plan that where it automatically buys low and sells high, and so he has PV as well as power walls and electric vehicles, but he doesn't, I believe this is true, he doesn't produce as many kilowatt hours as his home and car use, but because of the buy low, sell high, he makes money. So he's in terms of kilowatt hours, it's not enough for his household demand, but in terms of dollars, because of using the batteries to arbitrage, it comes out net positive for him over the course of a year, maybe even every month, but definitely over the course of a year. And so, yeah, getting you and him together over a beer or something would probably be fun.
Nerd out on that. Yeah, that's super cool. I mean, I believe it too, for sure.
Yeah. And in fact, thinking about that, I should mention lunches, which if you're available a week from tomorrow and you're able to come on a Friday, I don't know how your Fridays look, down to the Clear Lake area. Emma, who's there across the table from you, is the president of the JSC EV Enthusiast Club, and she arranges lunches. And we try to make it on days that are convenient to folks, and often it's on a Friday. And so this month it happens to be a week from tomorrow. And you get our regular notices in your email, right? Because you should be able,
Yeah.
if you're not getting the notice specifically about the lunch, ask Emma across the table from you there to put you on that list for the lunches. And yeah, because there's always great conversation. We kind of rotate between usually 3 different Clear Lake area restaurants, and it's always fun talking at one of those too. So
Okay, yeah, I'll keep my eye out for it.
Mhm. So something else I wanted to ask if you should happen to know, on the grid in Texas, I've often heard that at nighttime, and the word curtailed came up earlier, that we have so much wind power in Texas that sometimes it has to be curtailed. Is that still true?
That's my understanding. Yeah. I mean, someone else here may know more about it than I do, but yeah. I believe so. Yeah. I can't speak to details on that, but yeah.
'Cause I've heard sometimes it even goes net negative because there's just so much wind power available.
Yeah. I think that's happened before, for sure.
Okay. Do you ever recommend folks to get one of these free nighttime, expensive daytime plans?
Yeah. I was on something like that. In the past. I guess I never really did the analysis on whether it was like actually beneficial for me to have that or not. But yeah, I think that if you can, be careful with how you do things, or if you look at your usage profiles or whatever, and it makes sense for you, like, yeah, for sure.
Yeah, I often tell people only if you can control usage. In other words, if you have a couple of teenagers in your house, you may not want to have that because they'll probably tend to want to use power at the most expensive time and not but if you can control the people in your household and you have one or two EVs that you can definitely charge during those free nights, that it's something that for some people that's a good plan.
Yeah.
So I know that Robert Sanchez is on and he had sent you some questions ahead of time. And I don't know if Robert wants to talk at all about those questions that he sent.
Yeah, I can pull them up too.
So I don't know if you have the questions that he sent you earlier handy. I've got them here. I can read some of them off and we can modify the questions as well to, tune them more precisely to your expertise. But
Yeah, go for it.
so his first question was estimated cost for a mid to large size business, break even point in years.
Right, yeah, so, kind of what we've seen on the cost of electrification. So like one of the clients I'm working for right now, they're a food and beverage company, and they're electrifying their last mile delivery vehicles. So from their distribution center, they're taking their like food and beverage products and taking it to like the corner stores and grocery stores and all that stuff. And so they're going through an electrification effort, and their facilities, they have some sites that are like small, which would be like 20 vehicles, that are electrifying, and they have the Ford E-Transit, so it's kind of like a cargo vanny type size vehicle. And then they also have like a class 6 truck, so it'd be like the biggest U-Haul you can get essentially. And so they have some sites they're doing like 20 to 30. They have some sites where they're doing like 55 to 60 vehicles, and some sites where they're doing like 90, 95 vehicles. And so, the cost of doing install like that, we've kind of figured out that it's anywhere from 20,000 to $40,000 per charge port. And so that would vary on a lot of different things, whether it's a lot of like cutting through concrete because you have to like, get the saws out, dig it up and cover it back up. Or you can do a lot of like above grade conduit runs type thing. And there's like economies of scale. So if you're only installing, 25 chargers, do you still have to do all that work? Maybe it's a little bit more expensive versus like the 92 charger site where it's like, okay, well, we have to order this big piece of electrical equipment, but it's going to serve more chargers. So maybe there's efficiencies gained there. So we try to keep it around, maybe like $35,000 per charge port is kind of like our goal, which turns into like a $1 to $3 million installation, depending on how many vehicles are going to be there. And then, so that's the like upfront infrastructure cost. And then there's like the cost of purchasing the vehicle itself, right? So these electric vehicles are more expensive than internal combustion engines. And so, there's but then the operational cost is a lot less, right? Because there's a lot less maintenance needed on electric vehicles, and there's a lot less fueling that's needed, like the fueling cost, you know, air quotes, is less with electricity. And so, you know, what that break even point is, I think will depend on like what the fleet turnover is, that particular type of operations, and then like miles driven, how often they need the oil change on the vehicles, like stuff like that. But I think, you know, people see it as quick as like, you know, 5 years or less, they could have like a return on investment that's like in the net positive. So.
Okay, that's a good kind of idea there. So I'll shorten his next question. Any involvement with Metro or Houston Independent School District on buses?
Yeah, so, no, unfortunately not. We did work for Centerpoint, and then I know Metro's electrified a couple of their facilities, and we know Harris County's working on electrifying theirs from a previous meeting, right? And the problem that a company like Burns McDonnell has is that our lawyers and their lawyers will get together and try and hash out a contract, and there's the, you know, kind of the bumping of philosophies, I guess you could say, maybe, with the procurement processes. And so working for like a government entity like, you know, Metro or HISD, you know, what as we can do it as engineers, like I can figure out anything, right? But, you know, getting the business part of it is, so, you know, for the right project, we would definitely work for them, and I would love to. But yeah, we haven't done that yet. But we do, you know, like, so Maricopa County and out in Arizona, we did their electrification study. And so, you know, that's a little bit different than doing like nuts and bolts engineering and construction. You know, we did like a fleet roadmap for them where it's like, okay, if your goal is to go 100% electric by 2040, like how do you get there? You know, how many facilities do you have? How many chargers do you need at each facility? Which vehicles are you can convert? You know, what's the roadmap to get you to your goal? And so we did that study for them, and we're hoping that because we were able to work out that contractually, we can work out the engineering construction part of it, but, you know, TBD.
Mhm. So some of the club members, in particular Colin up at the front of the room there, we got to experience some of the Metro electric buses. And so that was a good thing. So yeah, we know that since we toured the Metro facilities and found out just how many new buses they get every year, because they're replacing out of like 1,200 buses, quite a few every year. Just due to wear and tear, and then they're trying to electrify a certain amount of them. I'm sure they're working either with your company or other companies to be sure that they're able to charge them then.
Yeah, that's 2 steps forward, 1 step back. I think they struggle with electrification, whereas some of the school districts seem to do much better. The one fact that I remember out of that entire tour that pops up in my head is the motor that they use in the Metro bus is the same motor they use in an N1 tank.
Yeah. Yeah, I remember hearing that too. Yeah.
And that one of the people that worked there was ex-Army, so he knew he could work on that stuff.
Yeah, that's crazy. Yeah, the city bus like electrification is kind of a cool, I think, success story. And like as far as converting like these like big heavy vehicles to be electric, you know, and I think that city buses are a good candidate for that because it's a lot of start and stop type situation, right? And they have a known route, so they know like, okay, this route is a good candidate for electrification because it's like, okay, they'll be driving 100 miles per day or whatever, and this is the battery size in the vehicle. We can charge it this much at, you know, this dwell time. I think that the industry kind of like had an unwritten rule that's like, okay, we're going to figure out city buses first as like these heavy duty vehicles, with the holy grail being these class 8 semi trucks that are doing like cross country routes, because it's like, okay, if we can electrify those, that's like, you know, emissions, and like that's like a little bit more of a challenge than like these like intra-city, you know, driving. So
Metro was struggling with it, I think, and Sci-Fair was very happy with their school buses, which don't run half the day.
right.
You know, they run a few hours a day, and they could run them in the local area, and they keep the diesel for the long all.
Yeah, the same thing with Metro, right?
Yeah, they were trying
They
that,
were
but
figuring out their routes.
they were having trouble, what seemed to keep coming up was they were struggling with parts and maintenance and it was not as simple and easy as you would hope, yeah. But, yeah, I think there's a little bit of that with any new technology, yeah.
Yeah, and I would certainly hope that they had like done the upfront planning and all that. And I'm sure they did to a certain extent, and it just, maybe didn't pan out, like, the numbers on the paper maybe not reflecting reality exactly, right, type thing, so.
They ran into, the, trying to charge all the buses at once too doesn't work.
Mhm.
The demand charge was just killed them, yeah. And they somehow didn't expect that, they needed you, obviously.
To do a study.
Yeah, and like the way that those commercial facility demand charges work is pretty, penalizing, where they like ratchet at that peak level that you set, and then you keep that for a year. And then once that year goes by, it'll go down to your next highest peak within that previous 12 months. You're stuck with that, until that one exceeds, 12 months or whatever. And so these, you pay for the electricity, and then you also pay for the demand. And so if those demand charges get ratcheted at something, you're stuck with that for 12 months, and that could be a killer, for sure. So.
Yeah.
Okay, looking at the next one of Robert Sanchez's questions, I'll just kind of shorten it. Looking at the mix of electricity sources, does that come into your calculations, or whether the electricity going onto the grid is from one source or another? Is that kind of all the same to you from your work?
Yeah, yeah, for like the specific work that I do, it's very much just like, okay, which parking spots do you want? And, how powerful you want the chargers to be, and we'll figure it out for you.
So the source of electrons doesn't play into it. Okay, I kind of thought that, yeah. And then he asked, what is the formula for designing and constructing a system? Current needs plus 5% growth of electric transportation, for example?
Oh yeah, that's a good question. So what we typically do is we try and figure out what like the day one install will be, and then what their final install will be, and then we build towards the final install. So it's like, for instance, like the food and beverage client that I'm working for, it's like if they know that their facility is not expanding and they're going to have like their 55 route vehicles, then we'll build towards that. Now, on day one, they're probably going to have like 10 electric vehicles, right? Because they're still transitioning their fleet over. And as these vehicles go out of service and new ones come in service, then they'll make those new ones be electric. But at the end of the day, they know they're not going to have more than like 55 electric vehicles at this facility. And so we'll design our like electrical infrastructure to support that 55. And if the client says, we want you to prepare, for 25%, spare capacity for any kind of future growth, then we'll all account for that. But, we're not gonna go in there and just be like, oh, well, we'll give them a couple extra 100 amps because we're feeling generous, because that all costs money, right? And so, we'll design to the specifications that we're given. And, if that includes some spare capacity, that would be dictated by the client.
Okay, and then his last question here, how do you break the permitting and inspection log jams?
Yeah. I'll give you my it depends answer on that one too.
That's the 15 weeks minimum.
Yeah. Yeah. There's permit expediters that we've gotten involved that, here in Houston and like in Texas in general, permitting hasn't really been an issue for us, but like up in the Northeast, it's been a real pain. New Jersey in particular, I would not recommend doing a project in New Jersey if you can help it.
Oh,
No offense to anybody from New Jersey, but yeah, like, here it's, you submit your engineering drawings for plan review, and some, engineer with the city will review them and provide comments back to you, and you go back and forth until everyone's satisfied. Some of the projects we've had, you have to submit your plans, and then you have to go before like a city council where they like opine about the benefits of having electric vehicles, and then it goes to like some kind of planner who is the first in a series of 5 people who have to review your thing. And, one person has a sticking point that you don't feel like is really a valid comment. And so, it's going to cost you more money to do this, So yeah, it's some places, a lot of hoops to jump through, and some of them are just like, oh yeah, okay, you're a licensed professional engineer in the state of Texas, like, and you've sealed these drawings saying that you know that, your design is like meets code and all that stuff, like, that's good enough for me. Like what you were mentioning earlier with the utility, I think is the bigger log jam, where the power demand that you're wanting to get at site, like once you sign the contract, first thing you do is go to utility and say, hey, we need, a megawatt at this location, like, let's get your process started first so that we can get the transformer on site, because it's like a 40-week or 52-week for like a 1500, EVA transformer type thing. So
Unless they have it in stock,
yeah.
every time a hurricane comes through, it just takes out all these transformers, so they do buy them ahead of time.
Oh yeah, I mean, there's definitely stock. They have the
But
emergency
it's
supply.
not for new projects. It's
Mhm.
for, if you can talk the right guy into it, maybe.
Yeah.
But it's gotta be the right guy.
Sure.
Otherwise, there's a huge time frame.
Yeah, and inspections too, like I know you mentioned that too, David. It's like there's some inspectors that will come to your site and like roll down their window and kind of be like, oh, okay, yeah, looks good enough to me. And then some people will go out there with like a voltmeter and be testing that kind of stuff. So, it runs the gambit.
Yeah.
A little ball thing. Oh, this paint's too thin.
Okay, so other folks online, Jason or anybody have any questions for John? Because this is the kind of stuff we could delve into your brain for hours and hours, I think. And that's why I bring up the EVs and beer or the lunch or both. And
Yeah, and I've got one of the client that we just finished a project kind of in the North Houston area, and there's like some cool construction pictures I took. So I don't know if that's like if you're hurting for a presenter sometime later this year, maybe I can come back and do a little show and tell.
Cool.
so, okay.
This may not be for John necessarily, but what about, CenterPoint's gonna start burying more transmission lines, I guess, for hurricanes. Does that, when you upgrade transformers and all those things, do you need to upgrade the transmission lines also? Will that make that harder, obviously, if they're underground?
Yeah, it's a good question.
I think it's close to 2.33 to 2.5 times more expensive. Because the further down you go, the cables get hot. And so you gotta beef up the cables. So then now you're talking about more copper or aluminum, which is now got tariffs on it. Anyway, think about that sort of stuff. But anyway, yeah, you gotta beef everything up. The further you go and the further down you go, so.
So it's just an extra little barrier. It could still be done, but it's just obviously easier when it's above.
expensive. It's very expensive.
Yeah.
Later on, when you start having problems with the lines, it's really hard to pinpoint the problem. It's not like looking up and looking to see where the fuse is blown. It's more difficult with underground.
The cables are not 30-year rated, they're 6 to 10-year rated. Because you're in water. You can't keep the water out of the conduits. You're in water. So those are gonna corrode, and then if you got any kind of nasty, what do we call it? High pH, it's gonna eat the cables faster. So the rating of the cable is 1/3 of the 30-year cable.
Wow. Okay. Good. More questions, discussion topics for John? So as I mentioned, John, we hope to see you at lots of future meetings anytime you can make it on a second Thursday.
Yeah, good. Thanks for Thanks for sitting and listening to me.
And of course, since I now know that you are driving a Kia EV, maybe we could get you to bring it out to one of our outdoor events, because we always like to have a variety of manufacturers represented. And so that brings me up to Eric Sweet's transition from one EV to another EV. And so he's mentioned that now that he's got his new Ioniq 5, he's interested in asking other club members if they're interested in approaching him about purchasing his BMW i3. So what you
I wasn't gonna go that route. I've been looking for a bigger battery, EV for a while and driving the i3. And I just really assumed that if I bought it local, I would trade it in. But I didn't buy it local, so now I've got to sell it. And the offers that I've gotten from the dealers has been so low. And usually when you're selling a car, you're like, okay, whatever, you just turn it over. Well, I had a little more time to think about it. And I thought, well, maybe I'd offer it up to the club. The offers have been like $1,500 or so for a functioning EV with a range extender. And, for an entry level EV, I thought, I could let it go for like $1,200 or something to the club. And if nobody buys it, that is fine. But I thought at that kind of level, I really have to at least offer it.
And you can put it on our Evo Facebook page.
Okay.
Yeah, that's a good way to do it. My neighbor just bought an i3, and it's an i3.
i3.
Yeah, and he loves it. I mean, I think it's his choice of car now, even
So
though
this
the
car's-
range is down on the car, but he loves it.
It's 10 years old, and the way they designed it has some issues, but it got me where I was going. And I just thought back to when all the years when I wanted an EV, and I would have loved to have it. But EVs are expensive, and so it took a while before I felt like I could pull the trigger. Well, this one's not, so it could make somebody happy. I thought I'd offer it up. So.
Good. So anybody who's interested, please contact Eric, or through the club, contact him. We'll get you in touch. So that's a real good thing. And John Atwood, if you're still there, I know that you brought a piece of hardware with you. A big, heavy piece of hardware.
Yeah, I'm still here.
Can you tell us about it?
Yeah, I'm in the corner over here. And
There we go. Yeah, so those of us online can see it. Yep, perfect.
yeah. So this thing right here that I brought, this is a continuation of something I brought a few months ago. And so this is part of my EV conversion that I'm working on, which is a Nissan Frontier mid-size pickup truck. And so what you're looking at is basically the rear hub. And I brought this piece right here. This is a piece I had custom made, and it's the outboard part of a CD shaft. So on a CD axle, you have one of these on each side down the outside, and you have one on each side on the inside. So these are the outside because they have the spline for the hub and the nut for the hub. And so this piece in the middle is just the other one of these that's in it, because I have two here. And so this thing is kind of heavy. It's over 50 pounds.
Oh, man.
And so you can see it looks like your wheel, right? Your brake disc and everything. So you gotta show the camera here. So this is a performance rear brake disc for the Nissan Frontier. And then this guy right here is the brake caliper. So this is a big old fat performance brake caliper with 4 pistons And then this guy over here on the other side that has the Tesla logo, that's the parking brake. So I went with a electric parking brake. So these are off the Model S. And so then I have this plate in the back, and this was the original stock plate from the Frontier. And I wanted to reuse this plate to make sure that I could still buy parts that were designed for a Nissan Frontier. So I could buy a brake and caliper and all that stuff. And it would bolt up, I wouldn't have that problem. But I had to custom figure out how to mount this guy on there, and I've done that. So then, of course, I have a CV shaft through. So this is just next piece. So I'm done with the hubs on the rear hubs. So I just have to work on actually connecting the axle together to the electric motor.
So it's not a solid axle?
Nope. Oh, that's a good question. So the truck did have a solid axle, with a regular differential, straight axle. And so I got rid of that because I put an electric motor where that axle was, where the original differential was. And so I went with a design called a DDon axle or DDon tube, which is very much like a trailer axle. Another name for it is a dead axle. The trailer axle, it doesn't drive the trailer, it just connects the two wheels together, and you have the brakes on the end, which this is the hub and the brake section. And so the DDon tube means that you do the same thing, but instead of the tube going straight across, you have the tube go in front, or you have the tube go behind, and that way you can leave a space in the middle to put like an electric motor that's going to drive the axle. And so then you'll mount the motor in the middle, and then you'll have CVs that go to the actual hubs. And they did it on the electric Ford Ranger. That was stock, the DDon tube. And it's used a little bit in the past. Anyway, I'm using it for mine.
That's in the rear?
Yeah, this is the rear suspension. And I wanted the DDon tube because they're good for holding weight, and it's a truck. So I didn't want to do a full independent rear suspension because it's still a bed. I still want to haul stuff. Do you have a question?
I was just gonna make a note that the new Mercedes G-Class EV also has a similar design on the rear.
Oh, interesting. That's the SUV.
The really boxy one.
Yeah, the G wagon. Yeah, nice. I didn't know they had an electrified version of the G wagon.
Yeah, it premiered early. Well, late last year.
Oh, that's pretty cool. I'll have to check that out. That's interesting. I wonder if they did it for like weight handling and off-roading and stuff like that. That's interesting.
I heard that somebody else did it.
Right, they're stealing my design. Mercedes. Yeah. Cool. Anyway.
So I have a question as well.
Yeah.
Is the regenerative part, or do you have regenerative braking? Is that all done at the motor side, or is there parts in the brakes that also assist in the actual regenerative part?
Yeah, no, you're right. It's just all on the motor side.
Okay, so basically it just engages the motor, and the back EMF is what's providing the, and then this is on top of that in case you need to stop faster than that motor would.
Yeah,
right?
And so this, I'm doing two motors. So it's two Tesla motors, one in the front, one in the back. And that truck had probably 250 horsepower, and so I'll have more like double. And so you should upgrade your brakes.
Yeah.
So how will you control it? Will it be like one pedal driving plus you got a brake, or?
Yeah, just the same as every.
But not the old Flintstones way of doing things. So
Yeah.
it sounds like,
Yeah. It'll reach in, and then if I have a problem, I will mash the brake pedal, and this guy will kick in. But it'll be to where this disc will probably look new for a long time, but it'll be there if I need it. So, and it's heavier, so that's great.
They're heavy anyway.
Yeah. So the regen just comes from the back inertia from the motor, the drag on the motor as you're not using it and you're putting down. If anyone needs to do curls,
That's
Cool.
fantastic. We always love seeing hardware and getting an explanation. Any other questions for John about his project?
Yeah, now I'm gonna go mount this thing on the car, so.
You only do Datsuns?
No, oh, Nissans?
Yeah.
Yeah, I guess so. Everything I've ever converted has been Nissan Datsun. Yeah, because my other car was a 510 wagon. I still have that car. I use it as a shelf right now. Because it's a station wagon, so I can use the top as a shelf and I can use the hood as a shelf. It's a great table.
Do you think you might get it going again by April? Because I know we've had Watson the Datsun out at Discovery Green before, John.
Yeah. We'll see.
We'll see. Okay, that's a good answer.
No promise.
It sounds like it depends.
Was that a
Yeah.
brown dot? Was that Datsun brown?
It was gray, like a gray color, gunmetal.
I remember at one of the Earth Days seeing a converted like old station wagon Datsun or something like that, or
Yeah,
maybe a hatchback. So that was okay.
yeah, probably my car.
It
Back when
just
that's
needs,
what most of the cars were. I think one or two Teslas, and then the rest were conversions. But okay, cool.
it just needs brakes.
Aha, yep.
Yeah, it actually doesn't have regen because it's an older style conversion. It has a DC forklift motor in it, and so it doesn't have regen. And it has drum brakes in the rear, and the drum brakes like glued themselves to the drum because and that's the parking brake, and so that's what happened to it. So I had to redo the brakes on it. It took me a while to get the parts, so and I'm waiting on that guy to actually do the work because I'm delegating that project. I'm working on this project
Okay, got it.
one at a time.
Good, good. So, any more questions for John or John or John? Okay. So in the chat, I see a couple of things here. So for John Nemec, any chance we could do a shop visit to your facility sometime? So something for you to think about. Because of course, there are a number of us, like I said, we've toured the metro bus facility and got to ride in their electric bus and stuff. So think about that. And then also he's asking, I have a lot of conversion books if anyone's interested. So yeah, there's of course a long history of conversions. I like telling people when I'm out with folks that aren't familiar with the history of our club and EVs that a lot of the early conversions used electric motors from electric forklifts, because electric forklifts using those heavy lead acid batteries and operating inside of warehouses where you didn't want to have combustion exhaust fumes being built up where all the people are at inside the warehouse, were some of the first vehicles electrified after, of course, the early, Baker electrics and things like that, 125 years ago. But yeah, so often clubs would do conversions using forklift electric motors, big heavy motors. And of course, forklifts loved having the extra weight because the last thing you want is your forklift to tip over. You got to have that weight on the back, which pick up heavy stuff with your forks. And so that's always good. So, Colin, if we're ready to go back to the meeting PowerPoint,
Okay.
if anybody has questions, please speak right up. So usually we're using this PowerPoint just at the beginning of the meeting, but I've thrown a few things in at the end. Thanks for helping with that, Colin. So I can add some stories here at the end of our meeting as we get toward wrapping up. As I mentioned, this meeting's recorded and it's going to be available on our YouTube channel, so folks can go back and look things up or.
Okay. Either one will do. I've got to share it though.
And I'll mention the lunch again a week from tomorrow. Usually we have a dozen or so people, so it's always good opportunity to chat about different EV topics.
Dave, this is Ken. So you said so are these NASA people or employees or
Well, it's
Clear Lake area?
the Clear Lake area is where we
People.
meet because it's organized from the NASA JSC club, but we're certainly not limiting anyone who wants to come down to the Clear Lake area, if that's not your part of town,
Right.
and join in. So, and we have a few, some folks are able to travel across town. So, it's just centered down there so it's aimed in that direction, but we don't limit it. Anybody who would like to.
I would probably be interested in going. I'm not sure. I mean, I did get the meeting notices for this, but.
And also in the chat, Robert's writing, would anyone be interested in placing our club business cards on EVs? So under a windshield wiper or wherever might be appropriate. Shopping centers, charging stations, movie houses, etc. It's a low-tech guerrilla marketing tactic. So yeah, for folks that are interested. So if you all can see the image on the screen, I've got it here now. It's titled up at the top, Dave in France. And so I just have been taking a few photos. And this happens to be an ID2, I believe it is, which I think is a model that's not available in the US from the Volkswagen ID line of EVs. So it was interesting to see that on the road there. So if you'd like to go to the next photo. And they have some electric buses. And this one says, I roll 100% electric. And I always like that electric with the QUE at the end. So, and they call this one the Palm Bus because it's a area here along the southern coast of France where they have palm trees. So that's why it's a Palm Bus. But this one's all electric. I've also seen they have some that are marked 100% biocarburants, so biofueled buses. So some of the ones that they still use that burn a liquid fuel are actually burning biofuels. Next one, please.
Always burning French fries.
So here's a couple more. So I thought of you, Eric, because this is a BMW i3 in the center. And also I caught someone on an electric scooter. So you do see some of those around here. Sometimes they're on a bike path. In this particular case, somebody is just riding right along in the traffic lane. So next one. So here's another little cute electric Palm Bus. This one happens to be painted pink. And here you do see some of those palm trees. And off to the right is the Mediterranean Sea. Didn't make it because that's not electric. Yeah. Okay, next. So here's another Palm Bus. This one is going up to the old castle up at the top of the hill. And I walked up the hill, but it was nice to see that they offer this transport to get people up, may not be capable of doing such a, I wouldn't call it a near vertical hike, but it was quite a slope to go up. And part of it was stairs, and part of it, like where this electric bus is driving, is just like a big ramp up to the top of this hill.
What city is it?
This is in Cannes,
Okay.
Cannes, Cannes, France. Yeah. So is that the last one, or do we have another one, Colin? Oh, yes. Here's the electric bus with a little bit of motion action. And here's our last video. So this gives you the opportunity to see that Mediterranean Sea. And there were a couple of friendly birds, so I was just taking the video. So this really doesn't have anything to do with EVs, but they were quite friendly birds. So this one let me get quite close.
Close enough.
I heard somewhere all birds are robots, so maybe it is robot.
Could be, could be.
Charging real well.
So this one didn't want to fly away, just like keep walking. So we just let it walk in the other direction. And then looking at the seagull, I kind of thought, well, I don't think this one's going to let me get as close. And sure enough, time for takeoff. So that's and it's replaying now, so you can go ahead and stop it. But yeah, that's what's happening over on this third of the way around the world. So it is about 7 hours later on the clocks here. So that's telling me it's about 3:20 a.m. And I will head on out. And any other things people would like to bring up in our meeting today?
And this is Ken. I mean, this may be stuff y'all know, but I've had my 22 EV6 for like 6 months, and I'll go down to Austin, and I have found that stopping at Buc-ee's, now that like 10 of the chargers there have the adapters built in. I'm not talking about like the ones that are coming out this month and next month, or how Tesla is allowing the other, OEMs to use their chargers. These are, some of them have the adapter built in the cable, for lack of a better description, the Magic Dock, I guess.
Magic Dock, I was going to say.
Yeah, so the Buc-ee, in case you're not aware of that, the Buc-ee's and Bastrop, have that capability,
Yeah,
which
really good to know. Yeah.
so I found just the reliability. I mean, they're cheaper than the other ones, in the city of Austin. So I found just stopping there and charging back up to 80 and and going, and so in case y'all non-Tesla owners weren't aware of that, it's worked out pretty well.
Yeah, that's really helpful information, because I was thinking like the only Magic Docks I knew of were like in Vermont and the West Coast or some such places. So it's good to know that there's some that are
Yeah,
here.
just like on my EV6, and I don't know if with the Nero it's gonna be the same way. I have to park. 3 of the spots have like the striped areas next to them, because I have to. The cables are so short.
Yeah.
I have to park at an angle, and to stay in the spot and not, try to go over to somebody else's spot. I have to park at an extreme angle, but so that's the only drawback, with the, maybe I'll keep probably for any of the Kias to use those, but it's doable.
Great. Yeah, it's great to see more cooperation between charging systems and
I think you have to use the Tesla app, correct?
Yeah, and it'll tell you if it has those capabilities. I can't remember where I even saw that, that was thing, but after that now, like I said, there's the, like if you bought a brand new Kia, a Hyundai, they'll send, the OEM will send like a free adapter, at least Kia and Hyundai are. I have a 22, so that's not
Anybody
one that's not going to void your warranty.
got that delivery from Hyundai or Kia?
Yeah,
No.
Yeah, so
the new Hyundai Ioniq 5s, the 2025 ones.
well, that one has the actual,
Or have
the Next.
adapter.
Is it Next?
Oh,
Yeah.
Or not adapter,
Yeah,
next
it's
plug.
built in.
You're right. So like the 24s and the 23s and maybe the 22s, yeah, you can. I think the Ioniq probably came out the same time, probably as the EV6. But yeah, you're right. They are going to start doing the default to be the Tesla. But yeah, I've seen all the, Chevys, Fords, Rivian, there at the Buc-ee's. So yeah, it seems to be pretty well used.
I've seen Rivians and Fords at the locations that are not Magic Dock.
Yeah, well, they're getting adapters.
Yeah.
Tesla's approved the adapters, for those. Yeah, so I think it's just Tesla. I mean, I'm sorry, Kia and Hyundai are the kind of the remaining ones, and those are coming out, now more or less or next month or something.
I heard
But you're right.
their Kia owners were getting somehow through and using their own adapters. But Tesla supposedly changed the software so they couldn't do that.
Yeah, you could trick you would just tell it your Kia was a Hyundai and it would work, apparently. But yeah, they got rid of that. They figured that out or whatever and got rid of that workaround or shortcut or whatever.
Interesting, yeah. Okay. And we will see what other new vehicles get onto the market here. And so I'd like to thank everybody for their participation. Thanks so much, John, for being our.
Thank you, appreciate it.
Gets us all thinking about those deep problems and such an engineering. Good. And thanks to everybody in the room who have helped set up all the video and audio for this meeting tonight. Appreciate everything.
Thank you.
Yep. Okay. So if we're ready to wrap it up for this month, then since February this year is a 28-day month, that means it's exactly again on the 13th next month that we will have our second Thursday meeting. So stay tuned for March 13th. And then, of course, in April, we'll be looking for some outdoor activities. And that'll be fun, too. So, all right. Thanks, everybody. We'll see you next time.
Good night, Dave.
Thanks.
Morning, Dave.
Au revoir.